Hey there, and welcome to Math 7, Unit 8, Lesson 3, What are the probabilities? Alright, so first of all, we have this question says, which game would you choose? So here's two games. In one game, you flip a coin, and you win if it lands showing heads. Alright, so we know that your options when you're flipping a coin, you have heads and you have tails, which means there are two total options for you, and you basically have a 1 out of 2 chance of getting, a head happening, right? So you have a 1 out of 2 chance of happening. Pretty good odds. Or this game where you roll a standard number cube and win if it lands showing a number that is divisible by 3. Well, our options are 1, 2, 3, 4, 5, and 6. And the only numbers that are divisible by 3 are 3 and 6. Which means in this case you have a 2 out of 6 likelihood of winning that game. So you're comparing the 2 out of 6 to the 1 out of 2 in terms of which game would you rather play and have the better chance of actually winning. So when you look at this here, we seem to have a better chance of winning when you're flipping a coin, 1 out of 2 chance, right? Or compared to 2 out of 6 chances right here. Sometimes it's good just to compare. If you take the 1 out of 2, if I multiplied it by 3 over 3, then I have 3 out of 6, and you can compare the two fractions that way and see more clearly that this one is indeed the one that has a greater likelihood of happening there. So what's possible? For each situation, list the sample space and tell how many outcomes there are. Now, a sample space is defined as the set of all possible outcomes. All the things that could happen when you run this experiment. That's the idea. So, if Han rolls a standard number cube once, what are the things that could happen? What are all the possible outcomes? Well, he could get a 1, he can get a 2, a 3, a 4, a 5, and a 6. That is the sample space. So the sample space in this case is 1, 2, 3, 4, 5, and 6. The number of outcomes, okay, how many outcomes there are, in this case here, is there are 6 possible outcomes. And that's found by just adding them up. 1, 2, 3, 4, 5, 6. We're not worried about the probability of it happening. We're just saying that there are 6 possible outcomes that could happen. That's the sample space for this chance experiment here. Looking at this Claire and the spinner, it says Claire spins the spinner 1 time. And you can see the spinner is broken up into really 4 equal sections. So if she spins it once, what are the possible sample space? Sample space is going to be red, blue, yellow, and green. Red, blue, yellow, green. They're all the same size, so they have the same chance of happening. So those are the possible outcomes. And in terms of how many outcomes, there are 4 outcomes that could happen there. For Kieran selects random from the word letters from the word math. Now math is made up of 4 letters, which means that the sample space, our sample space, is going to be the M, the A, the T, and the H. Again, in terms of outcomes, there are 4 possible outcomes because there are 4 things that he could choose from there. Alright, looking at the next question, same one continued here. Alright, May selects a letter at random from the whole alphabet. So her options, things she could select, A, B, C, and again this will go on all the way to X, Y, and Z, which means that there are a total of 26 outcomes. And finally, Noah picks a card at random from a stack that has cards numbered 5 through 20. So his card choices are 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. That is a sample set for what Noah could pick for the stack of cards. How many outcomes are there though? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 possible outcomes exist there. Now, using that information, what we did in those number 1, A, B, C, D, E, and F, let's look here. It says, which one is, let's compare likelihoods. Is Claire more likely to have the spinner stop on the red or the blue section? So looking back at Claire, she was a spinner. Is she more likely to have it land on red or blue? And when we look at those two, they are the same size, which means they have the same possibility of being landed upon. Okay, so in this case here, we would say that both are equally likely. They have the same possibility of happening. How about the next one? Is Kieran or May more likely to get the letter T? Well, Kieran was over here with the math, and the T was going to be 1 out of 4 choices. So she had a 1 out of 4 chance of getting that one. May is over here with the alphabet, and that's a 1 out of 26 chance of getting a T because she's dealing with the whole alphabet. So the one that had the greater chance is going to be Kieran because she only has to worry about picking 1 of the 4 possible ones. And then finally, is Han or Noah more likely to get a number that is greater than 5? Okay, so when you look at Han in the first one, the only possibilities for Han that are greater than 5, there's one number greater than 5 for him. So he has a 1 in 6 chance. But for Noah, he has all of these. He has 15 chances altogether, right? So he has a 1, and really he has a 1 out of the whole thing. Actually has a 15 out of 16 is the likelihood that he gets a number greater than 5. So Noah is going to have a greater chance there. Suppose you have a spinner that is evenly divided, showing all the days of the week. Okay, so days of the week. You have a bag of papers that lists the months of the year. Are you more likely to spin this current day of the week or pull out the paper of the month? So comparing days of the week and months. So here's our days, which is Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. There are a total of 7 of those, so 1 in 7 chance. And then compared to our months, which of course there are 12 months, so you have a 1 in 12 chance there. So which one are you most likely to pull out of the bag or the hat? We would say days of the week has the greater likelihood because there's a 1 in 7 chance of that actually happening there. Alright, let's turn to the next page. The next one's called What is in the Bag? So your teacher's going to give you a bag of paper slips with something printed on them. Repeat these steps until everyone in your group has had a turn. So as a group, guess what's printed on the papers in the bag and record your guesses in the table. So you're going to guess what do you think is in the bag. Now without looking in the bag, one person takes out one of the papers and shows it to the group, and then everyone records what's written on the paper and you print it down. Then you put it back in, you shake the bag, and do it again. Okay, so here's what we're going to do. I don't have a bag with me right now, but I'm going to go ahead and I'm going to put what's in the bag right here in a pile. I'm going to kind of shuffle these things up here. I'm going to pick one of them. Okay, push the rest aside and see what we have. So I drew the letter M. So what's on the paper is an M. Can I guess what's in there? Maybe I could say these look like letters. I don't know what they go to. Maybe it's going to spell a name, maybe something else. I don't know. I'll put the M back in the pile. Gonna mix them up a little bit here. Okay, pick another one out. And I got the letter D. Interesting. D. So I know it's still letters. Maybe it's spelling something like maybe mad, or maybe it's Monday. Maybe it's like spelling some kind of word. I'm not sure. Again, I don't know how many are in the bag, so I'm just going to mix them up and see what I come up with here. Now I can see a little better than you can see what's in the bag, but that's all right. Flip it over and we have a J. Wow. At this point, I'm not sure. I don't know what kind of word can be spelled with an M, a D, and a J. Just don't know, but we definitely have a lot of letters still. I'm not sure how many there are, but something's happening there. Okay. Alright. Mix them up again. Do one more. Let me get one more over here. Oh, we get the letter H. At this point, I know we have letters. Maybe it's the alphabet, ABCs. Perhaps. These are all things we could guess. I can't see a word that spells, so I'm not really sure. Okay, so questions. How is it different guessing the fourth time than the first time? Well, the first time we just knew a letter and we didn't know maybe it's spelling something. Could be lots of things. By the time we got down here, we knew it's not spelling a word, at least not a word that I know. And I just went to maybe it's something broader like the whole alphabet. Okay, what could I do to get a better guess of the sample space? Well, to get a better guess of sample space, I could look at all the items in the bag, right? If I knew everything that was in the bag or kept going until I figured out what was in the bag, I'd be able to guess what's inside the bag better. So the more samples, or the more guesses I took, or the more times I drew a paper out, the better I get. Now, if I look at all papers in the bag, or my guess is correct. Well, we guessed letters, alphabet. So let me take these here and let me see if I can flip them over so we can see them. And we have definitely a bunch of letters, that's for sure. Lots of letters there. Clearly it's not spelling anything, it's just a whole bunch of letters, isn't it? Right? So I have a whole bunch of letters there not spelling anything, but is it the whole alphabet? I can see A, B, C, D, E, F, G. I got H and I, a J, a K, an L, M, N, O, P. No, we stopped at P, at O, right? So when I look at there, I see I do have the ABCs, but I have ABCs only through the letter O, which is interesting. I don't have all the letters, do I? Just parts of them. All right. So are all of the possible outcomes equally likely? Well, sure. If I have the letters A to O and they're all the same size, yes, they're all equally likely to happen. And in fact, in this case here, it started off as a sheet that looked like this, and you can see that there are 15 different letters right there. Right? There are 15 outcomes that are possible, and they all have the same opportunity to come up. Nothing's repeated. So what's the probability that a fifth person would get the same outcome as person 1? Doesn't matter if you're fifth or first, because we're putting the letters back in the bag, I have a 1 out of 15 chance of getting that same letter as the first person and the fifth person getting the same letter. It's all possible because it's all likely to happen there. So probability of an event is a measure of the likelihood that the event will occur. Okay, and that's the key thing there. So the probability of an event is a measurement of the likelihood that the event will occur. Now what's key to remember here is that probabilities are expressed using the numbers from 0 to 1. 0 means it's impossible, and 1 means it's certain. So that tells you when we're looking at probabilities, we're not talking about percentages, we're talking about, you see a fraction there, we're talking about fractions and decimals as how probabilities are going to be listed here. And so you look at our samples down below, right? When we look at something like rolling a number cube, okay, you have 1, 2, 3, 4, 5, 6. So the probability that it'll land on a number 4, you have 1/6 that it gets a fourth there. So if all the outcomes are equally likely and there are n possible outcomes, then the probability of a single outcome is 1 over n. Okay? Just something to keep in mind there. So we talked today a little bit about probability, about a sample space, and we talked about something that's random as well, meaning that everything is equally likely to happen in the way it's set up. We're going to pause there, let you work on your homework, and we'll come back together and check it off in just a few minutes. All right, taking a look at the homework for Unit 8, Lesson 3, what are the probabilities? So list the sample space, and again, all these are the possibilities, right? Possibilities. The possibilities for each chance experiment. So what are the possibilities of flipping a coin? If I flip a coin, I could get heads or tails. That's pretty much it. Those are my possibilities. Okay, what are the possibilities for a random season of the year? So what are the season choices, right? You have spring, summer, fall, or you could say autumn, right? Winter, spring, summer, or fall. All you have to do is call, and I'll be there. Yes, I will. You got a friend. Okay, random day of the week. Well, we have Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. Those are abbreviations, of course. That's it. Number 2. A computer randomly selects a letter from the alphabet. How many different outcomes are there in the sample space? Now, you don't have to list the sample space. Just wants to know how many different outcomes are there. Well, how many letters in the alphabet? Well, hopefully you know there are 26 letters in the alphabet. What is the probability the computer produces the first letter of your first name? Now, I'll use an example. So my first name is Aaron. Okay, so the first letter there is A. Well, how many A's are in the alphabet? There is a total of 1 A, and I have a 1 in 26 chance that it can find my first letter of my first name. All right, cool. So 1 in 26. Same for your name too. Number 3. What's the probability of selecting a random month of the year and getting a month that starts with the letter J? So, probability of getting a random month, and it's also a J month. So, we have January, February, March, April, May, June, July, August, September, October, November, and December. So I have a total of 12 months, and out of those 12 months, there's January, June, and July. So there are 3 that happen to be starting with the letter J. So I have 3 possibilities I could draw. If I picked one randomly, I have 3 that would be a J out of the 12, right? And again, you could do 3 out of 12. You could write it as a fraction. But when we're talking about probability, a probability, remember, is a number between 0 and 1. So the fraction makes the most sense as being an actual probability. You could also reduce this down to 1/4. That would be okay as well. And of course, you could reduce that a decimal to 0.25 if you wanted to go that way. So that's some ideas. Number 4. E represents the weight on Earth, and M represents the same object's weight on the moon. So we have moon equals 1/6 E, or moon equals 1/6 of Earth. So we can write it this way. My moon weight is 1/6 of, because multiplication, Earth weight. And that's what this equation is saying. That moon weight is 1/6 of Earth weight. So what does the 1/6 represent in this situation? In this situation, the 1/6 represents your weight on the moon, it being 1/6 of the weight on the Earth. That's the 1/6 is. Okay? Give an example of what a person might weigh on Earth and the moon. So let's say, for example, that a person weighed, we'll do some simple ones here. Let's say you're a little kid and you weighed 60 pounds on Earth. If I weighed 60 pounds on Earth, then my moon weight would be 1/6 times 60, which becomes 60 over 6, which becomes 10 pounds on the moon. Right? So that's how that works out on that one. Again, I used 60 just because it was easy. So you might want to try a different number. Whatever your number is, multiply it by 1/6, and that will get you your moon weight right there. All right, a couple more here on the back side of review. So here's a diagram of, and this is the key word here, of the base of a bird feeder, meaning the bottom part. The bird feeder kind of grows up from here, okay? Which is in the shape of a pentagonal prism. Each small square on the grid is 1 square inch. The distance between the 2 bases, so pretend like you have a base over here, right? If it's kind of sideways, and then one over here, kind of thing, right? And so you have this base. So the distance from here to here is 8. But you have this base on this side, and you'll have one on top too, but the distance between is going to be 8. So to find out the volume, you want to find the area of the base times the height. Okay? That's what you want to do. Now, the height is simply going to be the distance, which is 8. So we know that's going to be 8. So we want to find the area of the base. Well, let's break this up into 2 parts. I'm going to chop this apart right here so I have a triangle and a square. For the square, I can see that it has 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5. So the area is 5 times 6, which is 30. The triangle is going to be found by doing 1/2 of the base times the height. So we have 1/2 times base times height. And so when we look at this one here, we have a base right there of 1, 2, 3, 4, 5, 6. So this becomes 1/2 times 6 times the height, which is 1, 2, 3, 4. All right, and 6 times 4 is 24, and half of that makes 12. So this area here is 12. So now when I combine those together, what I end up having is I have a base, the entire base here of this shape is 30 plus 12, which is 42. The area of the base is 42. So now I'm going to do 42 times 8 to find the total area, or total volume. That's 16. 32 plus 1 is 33. So I say 336, and these are inches. Inches cubed is the volume of that bird feeder. And finally, our last one here, find the surface area of this triangular prism. Okay, so we have this space right here, which is a 3 by 4. Okay, so that's the one space. This is 3 by 4, which is 12, area 12. I have the back side over there, which is 4 by 4. So 4 by 4 over here, 4 times 4 is 16. So 3 times 4 right here, this is 12. And then the bottom side, I kind of draw it like that, is a 5 by 4 base. So 5 times 4 is 20. Okay, so now we have all the sides there, and we now need to get the triangle right here. So this triangle piece, this piece right here, the two sides, we have 1/2 times the base, which is, you can do a 3 or a 4, but we use the right angle, times 3 times the height, which is 4. That becomes 12, and half of 12 is 6. And so one of them is 6, and the other side right here is also 6. So we're looking at having a 12 plus a 6 plus a 16 plus another 6 plus a 20. And we add those guys up. We have 18, 19, 20. Carry the 2, 2, 3, 4, 5, 6. So we have 60 units squared. Is what we have for our 60 square units, for the surface area of the triangular prism. All right, that's it. Have a great day, and we'll see you next time.